hopefully this Giga Berlin, this factory here, can serve as an inspiration.
The transition to hydrogen fuel cell technology will represent a radical departure from Tesla's conventional electric vehicle platform. Such a changeover was basically made because it was not possible to achieve economies of scale in the manufacturing of its inventory of battery cells. In this wider effort, Musk introduced Tesla's new hydroelectric propulsion system, placing it as one of the key pieces in the puzzle of the firm's technologies. At once, a number of interesting questions arise regarding this latest powertrain design. What innovative features make Tesla's hydroelectric system different from traditional ones? How would this technological lead redefine the future landscape, not only of the automotive sector, but also of its allied industries? Elon Musk's obsession with sustainability. From being one of the most pioneering forces for technology in modern times, Elon Musk, through his leadership at Tesla and SpaceX, brought a number of revolutions to the foreground. His relentless commitment to innovation gave birth to unprecedented breakthroughs in automotive manufacturing and space exploration. At Tesla, Musk went further than producing conventional electric vehicles and led a basic change in the transportation system. He successfully hastened the transition towards sustainable energy solutions by proving that electric vehicles have phenomenal performance capability and are highly desirable. It is also hoped that it doesn't stop at Earth's atmosphere, with reports stating that SpaceX has been working toward democratizing space travel and constructing a permanent human settlement on Mars. The audacity of the ambition has made Musk a real visionary in the technology world. Pioneering work on rocket reusability at the aerospace manufacturer has completely transformed the space industry. Through technological innovation, SpaceX turned reusable rockets from science fiction into reality, showcasing the company's incredible engineering prowess. That is surely one of Musk's biggest successes, turning far-fetched ideas into reality. Few must have taken it seriously when Tesla began its operations in 2003 with an audacious mission statement. During that time, electric vehicles were too impractical and inferior to take over from conventional automobiles. Not belabored by prevailing attitudes like these, Musk persevered to produce the groundbreaking Roadster, a high-performance electric vehicle that was to show huge possibilities in electric mobility. Over time, Tesla continued to develop models S, X, 3, and Y, each iteration pushing the bounds of battery technology, driving range, and autonomous navigation capabilities, furthering the desirability of electric vehicles among consumers globally. Elon Musk has shown huge interest in sustainable energy solutions, such as Tesla's Powerwall and solar roof technologies. Tesla's solar roofs have been engineered to create integrated energy systems for residential and commercial applications by coupling photovoltaic power generation with sophisticated energy storage systems. Indeed, these would be practical avenues toward reducing reliance on fossil fuels while promoting ecological sustainability. SpaceX has many history records in space exploration. Falcon 9 rockets mark the face of manufacturing efficiency by using a minimum amount of raw material to make rockets. Starlink is a constellation of satellites that hopes to provide internet connectivity across the whole world, reflecting the deep impact of Musk on technological development and innovation. Operating on an elegantly simple yet innovative principle, this technology harnesses water's potential to generate electrical energy. Whereas conventional combustion engines rely on fossil fuel and electric versions rely on batteries, neither is the clean source that today's world needs. The water engine relies on reverse electrolysis to function, a process more complicated in that it works in reverse from standard electrolysis. Standard electrolysis uses electricity to split water into hydrogen and oxygen. Still, in this type of electrolysis, described here as reverse electrolysis, these elements are joined together to produce electricity, its only waste product being water vapor. This makes for an extremely clean and green source of energy. The system works in a very structured manner. Through an initial input of energy, water molecules are split into hydrogen and oxygen, which are then stored separately in the vehicle. During operation, hydrogen is fed to the fuel cell, where the molecule is split into protons and electrons. The electrons are used to create the electric current that drives the motor, while the protons join up with atmospheric oxygen to form water vapor. Thus, water undergoes a cyclic regeneration into energy and back once more. A revolutionary development in sustainable environmental energy production. In the fuel cell, protons move across a special membrane to join with oxygen in the air, forming water vapor. With a sufficient supply of hydrogen and oxygen, this will continue to provide a very effective generation of electricity. A comparative study of this water-powered engine against conventional and electric ones is astonishingly astonishing. While the water engine promises a new era of clean energy, how does it measure up against electric vehicles? Let's explore how these two revolutionary propulsion systems compare in terms of efficiency and practicality. Elon Musk's electric engine versus water engine. Expert analysis suggests that traditional combustion engines burn their fuel at a very low efficiency of 20 to 30%, dissipating the rest of the energy as heat energy. On the other hand, electrical propulsion systems have much higher efficiency levels, lying in the range of 85 to 90%. However, electric vehicles do have some drawbacks despite their high efficiency levels, mainly their long recharging times and inevitable battery degradation during extended use cycles. The hydro engine has a middle course in terms of efficiency, offering about 60% energy conversion. Though its parameters of performance cannot be compared with electrical systems, it has vast ecological benefits. It is very promising for a clean future of transport. Besides that, the hydro engine shows outstanding range capabilities with high-density hydrogen fuel, keeping up or above traditional petroleum-powered vehicles. The most attractive part of this car is the fact that it will only emit water vapor while eradicating range anxiety. Unlike electric vehicles with their long charging cycles, the hydro engine will allow for quick refueling, much like conventional gasoline-powered automobiles. This combination of rapid resupply and ecological compatibility sets it as the revolutionary factor for the car industry. Among the biggest advantages, this technology would bring into being a huge decrease in carbon emissions, whereas the traditional internal combustion engines are big emitters of carbon dioxide and other pollutants that cause environmental degradation and accelerate the processes of climate change. The hydro engine would emit nothing but water vapor as its exhaust. In that sense, it is clean and environmentally friendly, a real alternative that will ensure our transition into a more feasible future. Put a little differently, the average car in the United States, operating solely on gasoline, produces some 4.6 metric tons of carbon dioxide annually. These hydro engines will eliminate all emissions related to such travel. Environmentalists point out that nitrogen oxides and other noxious pollutants will also disappear, further dramatically improving air quality in these cities. While electric vehicles represent a cleaner alternative to gasoline-powered cars, they are by no means green. The mining of battery materials, like lithium and cobalt, has ecological costs. Powered by electricity derived from fossil fuels, their carbon footprint reduction is less dramatic than many maintain. Hydrogen fuel cell technology is another alternative source of clean energy, having only water vapor as its waste, though the implementation of this is very challenging. Most production processes depend on natural gas, which emits carbon again. The intricacy of the process indicates the continuous struggle toward developing really sustainable transportation systems. However, the hydro engine provides promising strides toward cleanliness and sustainability in the future of transportation. Hydrogen storage and transportation are also surprisingly easy, considering that its low energy density requires high-pressure containment vessels. The ingenuity of Tesla engineers in overcoming this challenge is remarkable. Their engineers suggest using reverse electrolysis technology in their hydro engine design, which can overcome these issues with cleaner, more efficient processes. A final important factor, often overlooked, is economic viability. Hydro engines are significantly more financially cost-effective in the long run. Conventional internal combustion engines require periodic tune-ups, oil changes, and exhaust system replacements that amount to a decent deal over time. Electric cars have fewer moving parts, hence lower maintenance costs. However, for most battery replacements, costs are quite high. not to mention some environmental concerns. With fewer parts in its overall design and construction, the hydro engine is correspondingly less expensive to maintain and operate. The potential savings could make the technology more available to consumers. The hydro engine may soon emerge as a cleaner and more economically viable alternative to both conventional and electric vehicles. The constituent parts of the hydro engine, including fuel cells and electrolysis systems, are very durable and could well extend the life of a vehicle. Moreover, as manufacturing technology improves and economies of scale are achieved in large-scale production, the initial purchase price of hydro engine vehicles will fall and become more accessible to the mass market. Transitioning to hydro engine technology does have its challenges. However, the road to widespread adoption of the water engine isn't without its hurdles. Let's dive into the challenges ahead and the exciting opportunities that could help make this revolutionary technology a reality. Challenges and opportunities in adopting water engines. Tesla needs to enter into substantial monetary liabilities in developing refueling infrastructures. Either new facilities should be built, or the company needs to upgrade existing ones with water-based refueling technology. Equally, both the governments and the private sector have the obligation to make it happen as a worldwide dream reality. The discovery of the water-based engine would eventually reduce our dependency on petroleum products substantially, which could control fuel prices and tension emerging out of disruptions in oil supply chains. A switch to renewable energy resources could bring great economic gains internationally in the long run. However, from a positive perspective, such technological development is bound to generate jobs for the new and developing sectors associated with water engine research, production methods, and infrastructure building. One of the core issues Tesla faces is the industrial barrier to change. As it is, the entire structure of the car industry, right from manufacturing patterns to distribution systems, is firmly rooted in petroleum-based procedures. The established industry players are also very reluctant to switch to water-powered propulsion systems. In overcoming these challenges, Tesla will be able to exploit existing technology platforms and experience. For example, many of the principles involved in hydrogen fuel cell technology, such as design parameters and storage solutions, can be used for water engines. Such technology cross-fertilization can accelerate development timelines and deployment strategies. However, questions remain as to the future of Musk's water engine initiative. Will it revolutionize our approach to energy and transportation, or will it get killed by growing opposition? The automotive sector received Musk's announcement with interest, as most players in the industry agree on the disruptive potential of this technology. In a broad market, Tesla Motors will have to advance a few key things: efficient reverse electrolysis, a broad network of refueling with water, and reliability and safety standards for the technology. Succeeding at the above challenges would make water engines able to shake up the auto segment and point the way to an ecologically conscious future. The response from the major industry players to Musk's announcement proved interesting. Auto giants Toyota and Hyundai have been staunch proponents of hydrogen fuel cell technology for quite some time now, but their reactions have been mixed since Musk's announced plans. Industry analysts said that Toyota views Musk's entry as vindication of their long-espoused commitment to the technology and acts as a catalyst for greater acceptance and significant investment in hydrogen infrastructure. Over the years, Toyota has been investing heavily in hydrogen engine research and development. On the contrary, Hyundai has been more cautious in its hydrogen engine research and development. Recently, news reports indicated that Hyundai was still very reluctant to invest heavily in hydrogen and water-powered engines. While some governments hail it as a revolutionary breakthrough that could radically speed up the world's switch to clean energy, others are more skeptical of its real-world prospects. Joseph Ra, a former official with the US Department of Energy, even described hydrogen cars as the least efficient and most expensive ways of cutting greenhouse gas emissions. Furthermore, Ra claims that building a national network of hydrogen refueling stations would be beyond the financial reach of both individual investors and governmental entities. A group of over 100 researchers, led by Professor David Shawn of Cambridge University, has also questioned the environmental credentials of hydrogen-powered vehicles proposed for the 2024 Paris Olympics. Their study indicates that hydrogen cars use 3 times as much renewable electricity as battery electric cars. They further note that in most cases, hydrogen is derived from fossil fuels, which nullifies its supposed environmental friendliness. Maybe Tesla's water-powered engine technology will change these criticisms. Whichever way the experts argue, public acceptance will always have the final say on what happens to the technology. But the question lingers. How has the general public responded to Musk's water engine ambitions? Public reaction to Elon Musk's announcement. The groundbreaking announcement of Tesla's innovative water engine by the firm's chief executive officer, Elon Musk, sent ripples of mixed excitement and skepticism through the ranks of industrial observers. Ecological activists and Tesla supporters immediately began circulating optimistic predictions of what this propulsion could mean via various social media sites. To a lot of supporters, that greatly diminished hazardous emissions, considering new ways to provide sustainable solutions for mobility, was an appeal. Not everyone was that optimistic, though, as Musk had dismissed the concept in the past. His sudden about-face on hydrogen technology raised some eyebrows and created rampant speculation about why this dramatic change in perspective had occurred. An apparently very basic problem cropped up when experts examined the wider implications for implementation. This would need an entirely new refueling infrastructure, which is a major barrier to widespread adoption. The more traditional fueling stations remained as ubiquitous as ever, while electric vehicle charging networks continued to grow in leaps and bounds. Emulation of such infrastructure in support of this new breed of water-powered vehicles would entail huge capital investment and considerable effort, no doubt. The final feasibility of this technology rested on the overcoming of 3 critical challenges. First, developing more efficient and economically feasible processes for reverse electrolysis. Second, providing an extensive, accessible refueling network. And third, overcoming continual public apprehension about operational costs and safety. If Tesla overcame the technical and logistic challenges, then water engines could potentially change the transportation sector and mark a path toward a greener future. But the road ahead was still filled with uncertainties that only time could sort out. Contrasted to the developed ecosystem of conventional fueling infrastructure and the growing network of electric vehicle support, hydrogen fuel cell technology remained in its infancy. Hydrogen refueling stations remained sparse globally, with higher concentrations currently existing only in certain areas, such as California, Japan, and parts of Europe. While this budding network laid a very basic infrastructure for water engine technology, requiring similar hydrogen-like refueling methodologies, significant network growth would have to be provided to help ensure wide market penetration. Clearly, the positive news had to do with Tesla unveiling its overall strategy for infrastructure development. According to insider sources, plans will be drawn upon Tesla's established expertise in EV charging infrastructures. It therefore made a 2-pronged proposal, adding hydrogen refueling capability to the currently existing EV charging stations and building purpose-built facilities specifically engineered with water engine technology. This ambitious initiative called for deep financial commitments and close coordination between government agencies and private sector entities to ensure end-user accessibility. Yet several key questions lingered regarding when the network would be set up and through what complex barriers to logistics and finances. These considerations became increasingly important as Tesla forged ahead with its plan to install water engines. Infrastructure construction cost, guaranteed production and distribution logistics of hydrogen, regulatory issues for compliance and public acceptance. The list was endless and had to be overcome systematically if the integration of technology was to be accomplished. Since safety considerations for this water engine have been of utmost importance, just like with the development of any pioneering technology, one critical design concept, vulnerability, called for closer attention. While hydrogen promised clean generation, the volatility of the substance and the demanding requirements to keep the gas in check asked for meticulous attention to detail. That the water engine effectively turned water into hydrogen made it inherit the same safety complexities. To mitigate these risks, Tesla introduced numerous levels of protection. Most importantly, the corporation fitted the carriage with advanced systems for hydrogen retention that would offer a safety warranty for storage conditions in the vehicle. In fact, these did undergo extensive stress testing to establish their capabilities in resisting the most extreme pressurized cases and resultant leakages beyond the limits set by relevant international regulatory agencies. With such steadfast commitment to safety through both development and deployment phases, Tesla aimed to make the water engine a dependable and secure technological advancement. Nevertheless, uncertainty lingered regarding whether these safety provisions would sufficiently assuage public anxieties. Establishing trust and maintaining public confidence would require sustained communication and transparency regarding safety features and operational protocols. Other initiatives that might have been explored include special public awareness and independent safety certification programs to further bolster the water engine's reputation among the general public as a legitimate and credible alternative propulsion system. Legal and regulatory requirements. The hydrogen storage, transport, and utilization protocols also differ considerably across different jurisdictions in the world. In all cases, Tesla has to penetrate the market by constant engagement with government oversight committees. For such agencies, standards to be met are numerous, while any deployment in masses also needs formal validation. Reality is not as simple as it seems. Let us elaborate on how things work in sequence. It begins with extensive documentation and intensive examination processes, along with continued coordination with the regulatory bodies. In such a way, by overcoming various hurdles and matching up to changing requirements, Tesla overcame bureaucratic barriers. An important question persists: at what cost? Even though hydrogen fuel cells show great promise, they come with their own set of challenges that can't be ignored. So, how do water engines stack up in comparison? Let's explore how these innovative systems may offer solutions that overcome the hurdles hydrogen technology faces. The case for water engine. By comparison, water engines and hydrogen fuel cells present different characteristics. Hydrogen fuel cells are very powerful and have a very high energy density that could allow driving for longer distances and refueling quickly. They also emit only water vapor as exhaust, which is ecologically friendly. However, there are serious problems concerning the manufacturing, storage, and transportation of hydrogen gas, which is highly flammable and requires special installations. Water engines demonstrate superior proficiency in on-demand hydrogen generation. This characteristic enables enhanced storage solutions and minimizes risks associated with hydrogen gas handling. Moreover, water engines are fully compatible with renewable energy sources, hence furthering sustainability. On the other hand, reverse electrolysis involves a large initial input of energy that might affect the overall efficiency of the system. Water engines will be viable, finally, depending on various aspects, such as overcoming technical barriers, establishing infrastructure facilities for refueling, and finally coming up with a product having realistic competition for hydrogen fuel cells and battery vehicles. From our discussion, we did notice the amount of research and development required for water-powered vehicles, not to mention the investment involved. Now, you might wonder about the profit involved, specifically from Tesla and any future investors. The water engine will be a promising but challenging market prospect. Fortunately, the automotive industry is gradually shifting to low carbon emissions and alternative energy adaptation. Regional governments across the globe are setting limits on emissions while providing incentives for clean energy technology, opening a very favorable door for inventions like the water engine. Therefore, innovators like Elon Musk are not alone in this mission of taking care of the environment. Market potential. Among the early adopters, potential customers for the water engine target will be some early adopters and customers already predisposed towards green technology. As technology improves, all this will also be reflected in better economics. Indeed, several analysts have already speculated that, with Tesla overcoming key efficiency issues as well as scale manufacturing and infrastructure deployment, this could capture most of the share in the next 10 years. Tesla has to form some alliances in the public and commercial sectors too, so that its growth is all-round and sustainable. Water engines cannot survive long in a truly competitive market. First, there are already tried and tested battery electric vehicles to contend with. Another is the hydrogen fuel cell vehicles. Each has relative merits and disadvantages. Among the principal factors are costs, range, refueling times, and, importantly, emissions. Besides Elon Musk's determination and the ingenuity of Tesla engineers, a number of factors will determine the market success of water engines. These include government policies, technological discoveries, and consumers' needs. Today, uncertainty surrounds these elements. In particular, they are changing continuously. The water engine is one that constantly has to change if it is to remain competitive in these changing times. If all factors come together, technological development, strategic alliance, and enabling policy, the technology will be successfully deployed. If these factors fall into place, then water engines can bring a sea change in the automobile sector and make a definite contribution toward a cleaner, greener future. Let us put this into historical perspective. Engine technologies have their roots in the creation of the first steam engine way back in the late 17th century. The dream to improve this original design belonged to two far-thinking pioneers, Thomas Newcomen and James Watt. It created a new axis for transportation and industry. Eventually, the invention of steam-powered engines propelled an industrial revolution. Internal combustion engines appeared at the end of the 19th century and were invented by innovators such as Nicholas Otto and Rudolf Diesel. The revolutionary four-stroke and diesel compression ignition design set the bedrock for modern gasoline and diesel engines. The new engines, much more efficient and powerful, found their ready market in automobiles, aircraft, and marine purposes. Major improvements to internal combustion would continue through the 20th century, with advances in materials science, fuel injection systems, and turbocharging technology. In this process, performance metrics, fuel economy, and emissions control all improved to the point that internal combustion became the backbone of modern transportation. However, concerns about pollution and the depletion of fossil fuels intensified the search for alternative forms of propulsion. That brings us to the late 20th century and early 21st century, where, with the appearance of electric cars, a supposedly cleaner, greener replacement of combustion engines finally came into focus. This new phase in engine evolution imposed a compelling need for environmental sustainability. As guided by Musk, Tesla was spearheading the revolution in EVs with technological advancements in battery technology, driving range, and charging infrastructure development. Ironically, the quest for alternative fuel technologies actually began well before Musk's latest undertaking. Remember that hydrogen fuel cells date as far back as the 1960s, when NASA used the technology to power spaceships on Apollo missions and proved the concept feasible. However, commercial-scale production eluded many due to a variety of reasons. For example, the cost of producing hydrogen, building storage infrastructure, and distribution facilities was just too expensive. Yet another remarkable effort toward a replacement or substitution for internal combustion engines was the development of biofuel engines in the early 2000s. There is significant interest in biofuels such as ethanol and biodiesel, manufactured from plant materials and organic waste. While offering a renewable energy source, biofuels had some setbacks. To manufacture even reasonable amounts, large areas of agricultural land and water were needed, raising food security and environmental sustainability concerns. Electric vehicles in themselves are a big technological paradigm shift. The earlier models of EVs, such as those by General Motors with its EV1 in the 1990s, showed great potential for electric propulsion, although their limited range, high costs, and inadequate charging infrastructure hindered large-scale adoption. Only after substantial breakthroughs in lithium-ion battery technology were achieved and wide-scale charging networks became available did EVs start to reach their potential. One particularly important lesson one can draw from past experiences with alternative fuel technologies is that infrastructure matters. Hydrogen fuel cells suffered great setbacks, just like early EVs, because there wasn't enough infrastructural support. Musk tries to bypass this issue by using Tesla's current supercharger network for hydrogen refueling. Biofuels, though renewable, mostly require more energy at production compared to what they yield. Keeping that in mind, Musk is working on perfecting the process of reverse electrolysis with his water engine in order to get efficient water splitting and hydrogen-oxygen recombination. It places Musk's water engine in a historical perspective as representative of the state-of-the-art in the search for greener, cleaner engine technology. Musk learned from past successes and failures and tried to push those boundaries even further. He would like to be ahead of the limitations of the previous alternative fuel technologies, capitalizing on infrastructure and expertise developed for electric vehicles. Thus, if ever you are in doubt over the viability of Musk's interest in water engines, consider how engines have been developed over time. The future of Tesla engine water technology. The water engine of Tesla serves as a promising move toward greener transportation, but a number of other companies are emerging as potential rivals. Among them, Nikola Corporation has become a big competitor in the hydrogen-powered truck market, showing very strong resistance through several setbacks. With their main focus on commercial markets, there is heavy competitive pressure on Tesla, especially in the long-haul trucking sector. Tesla has never missed a beat in forging strategic partnerships toward the achievement of its technological milestones throughout its life. It collaborates with various automobile manufacturers, energy providers, and research facilities to accelerate technology development, build infrastructure, and cut costs, which will similarly benefit the rest of the industry and consumers. Competition will be fierce and dynamic in water engines. The success of Tesla will depend on its technological leadership, outrunning rivals in strategic partnership making and moving with changing market demand. The avenues for cooperation it retains are with leading technological companies, universities, and research institutions to conduct exclusive research, possess specialized knowledge, and make use of the latest technologies that speed up the process of development regarding water engines. Collaborative efforts with research centers in the field of hydrogen could yield marked improvements in terms of efficiency and performance. A materials science department could find methods to construct more robust, better-performing electrolysis systems, while logistics in hydrogen may bring about more safety and compact solutions for storage. Besides, tech giants like Google and Apple could join for better software or even AI capability enhancement within water engine vehicles. Beyond immediate applications, the production of hydrogen to feed the water engines must be considered if true environmental sustainability is to be achieved. Hydrogen could be produced, for example, through the electrolysis of water using solar or wind power. Envision residential solar installations producing hydrogen fuel all day long to power water engine vehicles. But applications for water engines go far beyond automotive. Insiders in the industry confirm that Tesla is exploring aviation applications. Water engine vessels will considerably reduce global shipping's ecological impact and improve marine ecosystems and the atmosphere. The water engine initiative acquires special significance because the shipping industry is a heavy contributor to Earth's greenhouse gas emissions. The water engines would thus be a friendly alternative environment for some of the high-energy using industries of humankind by assuring a lower fuel consumption and corresponding emissions. With this, technologies can make a long way to changing manufacturing, mining, and construction industries with substantial transitions into greener sources of energy through sustainable solutions. The water engines may someday drive transport, power generation, and industry processes that make for a greener future. Thank you for watching. See you on the next.